Alright, monomial multiplication is fairly easy. Let's say you've got yourself a term or a monomial, 2x y squared, and you're going to multiply it by another number. Let's say 8x2y3. The process in doing this is fairly simple. Now, 8 times 2 is still 8 times 2. All this other craziness around it doesn't change the fact that it's 8 times 2, so we will still have a 16 out in front. I've got 1x here, 2 more multiplied in here, so a total of 3 x's multiplied together. 2 y's multiplied here, 3 more here, so a total of 5 y's multiplied together. This is the answer. Now, some of you look at that jump and go, man, that's crazy. I have no idea where this happened, no idea what's going on. There's a way to do it where you can see all the pieces come together, and that's by writing it out the long way. Now remember that exponents are shorthand for repeated multiplication. So 2 times x times y squared times 8 times x squared times y cubed. If you get confused with how to go from here to here, there's always an intermediary step. There's always a middle point that you could write out that we don't, because it's easier to go fast if you don't write out this step. It takes a lot of time to write this out. However, if it's the only way you can understand how to do it, it's an excellent method. Now here, you can still see that we still have 2 times 8. 2 times 8 is still happening, still 16. But the exponential values on your variables are a lot easier to see. I have 1, 2, 3 x's multiplied together. I have 1, 2, 3, 4, 5 y's multiplied together. Thus, that y5. Let's look at a slightly more complicated situation. Let's say we have 2xy squared, just like we did upstairs, and we're going to raise this to the third power. Now, again, a lot of people can go straight to the answer. 2 cubed is 8. If I have 3 x's multiplied together, that's x cubed. And if I have 3 y squares multiplied together, that's y6. And again, a lot of you look at that jump, and it's a little crazy. Alright? You don't want to do that all at once. Your mind can't handle it. That's fine. There's ways to get around it. I've got 2xy squared multiplied by itself 3 times. We're going to use the same idea we did last time. 2xy squared times 2xy squared times 2xy squared. This gives us the written out version of 2xy squared cubed. It's all together. It's all out where you can see it. And if this doesn't help enough, you can always write it out the longest way. So we have 2xy squared cubed. And it's all written out. These are all the terms all the pieces we're about to multiply together. 2 times 2 is 4, times 2 is 8. That gets rid of those. We have 1x, another x, another x. That's 3 x's we have multiplied together, so x3. And then we have 1, 2, 3, 4, 5, 6 y's multiplied together. And there you go. That's where that 8x cubed y6 comes from. Now, the last level on monomial multiplication looks like this. You're going to have several pieces all at once. 3x squared y times, let's just say, 2x squared y cubed to the 4th power. Let's get a little crazy. On this one, you have 2 pieces. You have this 3x squared y and this 2x squared y cubed to the 4th power. We're going to take care of this piece first. I'm going to keep my 3x squared y, and I'm going to execute this piece. 2 to the 4th power is 16. X squared to the 4th power is x8. And then y cubed to the 4th power is y16. Oh, it's y12. No, listen. Alright. So we have this one all pieced together. And now we just have 3 times 16, which is 48. 2 x's here. 8 more multiplied in here, so a total of 10 x's multiplied together. 1 y here, 12 more here, a total of 13 y. And that's monomial multiplication.